Welcome to Beyond Chips, the Chips.eu podcast, where we explore people, projects, and partnerships shaping Europe's semiconductor future. I'm Luciano Gaudio, Head of Communication at Chips Joint Undertaking.
And I'm Vasily Peglidou from the communications team. Together, we'll be your hosts as we speak with researchers, innovators, and industry leaders behind the technologies powering Europe's digital and green transition.
In every episode, we'll go behind the scene of Chips.eu founded projects. We'll hear stories of collaboration, innovation, and real-world impact, from lab to the fab and practical application.
Whether you're part of the Chips.eu community or just curious about how semiconductors are quietly transforming everything around us, from farming to mobility, you're in the right place.
Our conversations are guided by a shared principle: clear, respectful, and inclusive communication, just like how we work every day here at the Chips Joint Undertaking.
So let's get started and meet the people behind Europe's chip-powered future. Welcome back to Beyond Chips. Joining us today is Patrick Pypes from the Chips.eu funded project TRISTAN, a project building a secure and sovereign European RISC-V ecosystem. TRISTAN is creating industrial-grade IP blocks, tools, and open-source hardware to strengthen Europe's independence in advanced computing. Patrick, thank you so much for being here. Can you briefly introduce TRISTAN and its main objectives?
Yes, so the main objective of TRISTAN is to industrialize RISC-V technology within Europe. As we all know, RISC-V is grown from a university environment. And in fact, some startups have been created around it. Academia is using it, but large industries have not yet encompassed the RISC-V technology. China, India, and the US have been very aggressive on introducing RISC-V. And with TRISTAN, we want to introduce RISC-V throughout Europe and get it really more known and build a full ecosystem of hardware, software, tools, etc. And also a number of demonstrators to prove that RISC-V is a worthwhile technology to use.
So is this what motivated the focus on RISC-V as the foundation for TRISTAN, wanting to bring this technology more in Europe, make it more prominent?
Exactly. Because we all know that ARM is currently the market leader. And of course, we will still use the ARM technology, but RISC-V is a technology which is open source and which can be used for different types of application. And we want to show that for certain applications, RISC-V is a valid alternative for the ARM processor technology.
You mentioned open source hardware. How does open source hardware contribute to Europe's technological sovereignty?
Well, the advantage of open source is that it is freely available for everyone. And within Europe, what we can do is use this open source, distribute it to other partners, but also build around confidential technology and build commercial solutions and competitive solutions on a worldwide market with the open source as a core technology within it.
Okay, and can you say a little bit more about what are industrial-grade IP blocks and what kind of such blocks are you developing and who are they for?
Yes. In fact, one of the issues if you use open source is that often the quality is not good enough for industrial usage. Also, the model of support, for example, is not elaborated upon. You can just use it, but if something goes wrong, you have to solve the problem yourself. This is not what the large industry accepts as a model. So therefore, we really want to make industrialized, qualified IP, which can be certified, which can be used in different applications. For example, if you look at the automotive sector, you really need safety, security, and this has to be guaranteed. And that you can only do if you build industry qualified IP. IP blocks, this is different elements. This can be a processor core, this can be memories, this can be different types of peripherals, communication blocks, and you have to put everything together, both hardware as well as software, because you also have to run software on the hardware. And therefore, you really need to industrialize this with a quality that different partners can use it and that it is fully supported by the ones who are developing it.
And what kind of challenges do you face in building such secure and scalable toolchains, or in general in your operations with the open source hardware?
Well, first of all, to make sure that it works 100% according to the requirements that everyone puts on it. Second is also to get it distributed in a fluent way. And therefore, we have set up a repository where people can get access to, see what we have developed, use it, and give feedback on the quality, and as such, continuously improve the quality. And we have done this in cooperation with other projects, like with the Isolde, Rebecca, Rigoletto, which are also RISC-V oriented projects with different, I would say, objectives and with different outcomes, but where we want to distribute the IP developed in all this project in a common way throughout Europe towards industrial users.
It's really great to know that our own ChipsJU funded projects are collaborating together.
Exactly, yeah.
So speaking of this collaboration, how do you collaborate also with academia and industry within the project, apart from, like you mentioned, the collaboration with the other projects?
Yeah, as I indicated, RISC-V has been mainly developed by universities, and therefore we need to work together with these universities like ETH Zurich, University of Bologna. They are the number one players of RISC-V in Europe from an academic perspective. And therefore, we need to work with them to ensure that we use the good technology and that we can industrialize what they have already been doing in the past. Secondly, we also have to work together throughout the value chain. If you build a demonstrator, this can be an automotive demonstrator, a space demonstrator, an industrial, a health demonstrator, and you have to get the right partners to build the full system, whereas the semiconductor companies build typically the hardware. You have software companies which run the software on top of it, and then you have the OEMs or the system companies who build the complete demonstrator and the complete system to get exploited on the market.
And you briefly mentioned a little bit, you just touched upon the industries that Tristan is supporting. Can you give any other examples of how Tristan is supporting innovation in a specific sector like automotive or industrial automation?
Yes, in fact, what we have been doing also in the scope of the Tristan project is we have been sitting together with the European semiconductor companies like ourselves, NXP, but also Infineon, ST, Bosch, and together with some other partners, we have decided to work on a roadmap of RISC-V within Europe. And this is a roadmap from 2026 to 2035. What needs to be developed for the automotive sector in terms of processors? And you have different types of processors, 32-bit, 64-bit real-time processors, application-specific processors. It's a whole bunch of processes you need to develop, and therefore we have made a roadmap. Tristan is building the real foundational IP to implement this roadmap, and we have follow-up projects which will then build the elements of the roadmap towards the automotive sector.
And how does your project make RISC-V more accessible for SMEs and startups? Is there anything specific that you have done to make this technology more accessible?
Yes, in fact, I already mentioned the repository, which is in fact a collection of all the IP we developed. We are also, for example, organizing special sessions at the RISC-V Summit, which is a yearly event, where in fact we demonstrate what we can do with the IP in this repository, and where we invite academia, SMEs, also large companies, to show what IP we have and how they can use it to build their applications.
And what is your vision for RISC-V adoption in Europe over the coming decade? I assume this will have to do also with these other projects, perhaps.
Well, yes, RISC-V is really a core technology for the future embedded processors. And we see ARM, of course, will still be a big player for certain applications. But for other types of application, RISC-V will become definitely the number one. We see already in China, the US, India has stated a very aggressive move towards RISC-V. And I think in Europe, everyone is now fully aware that RISC-V is the processor of the future, and that this will become, in fact, very important for future developments in Europe.
And one last question. How has the ChipsJU funding supported Tristan in scaling and coordinating this ambitious ecosystem?
Well, I think without that funding, the process would have been much slower. It has really helped us to accelerate the process. First of all. Secondly, it has helped us to work together. I think the semicon companies, which are competitors in certain domains, now have found a common idea on what do we have to develop in common in order to access the market and build our future competitive products. And last but not least, for example, these companies, Infineon, NXP, ST, Bosch, together with Qualcomm and Nordic, have created a new company called Quintaurus, which is a company which will be a key player of RISC-V in Europe in order to certify cores, to help on the development technology, on the process to make sure that the safety and security is guaranteed, and in order to really have a European sovereign model to build based on RISC-V.
Well, thank you so much, and I wish you all the best with the rest of the TRISTAN project. And maybe we'll have a second opportunity for an exchange and we hear more about that. Thank you.
Okay.